Okay, boys and girls, this is Mr. Knoll bringing video notes for Lesson 20, the problem-solving lesson on area of composed figures. Hopefully this video finds you well. You're having a good day. Sorry I can't be there. We are hopefully getting good news on health of my wife's hip and recovery from her surgeries. So work along with me. Pause if you need to pause to catch up or slow me down. And let's get through this. You will be responsible for completing pages 215 and 216 for homework tonight. I will collect that tomorrow. So let's get started. Taking a look at the first page, read the example. Unpause the video when you are done reading, and I will guide you through questions 1, 2, and 3. Hey, number 1 says in the area, why is the area of one triangle multiplied by 2? Very simply, there are two identical triangles. So that's just saying if we find the area of one, to find the area of both of them, we multiply the area of one of them times 2. Number 2, find the dimensions of one of the shaded triangles from Bev's pattern. That's just counting the base and the height of that triangle. So the base is 4 units. And the height is 3 units. Okay, when counting the height of a triangle, you count from the base of the triangle to its highest point. And that highest point is 3 units above the base. What can you say about all the areas of the shaded triangles in Bev's pattern? The areas are all the same. And they're all the same because they have the same dimensions. Taking a look at number 3, what is the total area of the 6 shaded triangles? Well, we got to find the area of one of those triangles, so we take 1/2 times the base, which is 4, times the height, which is 3. So area of one of those triangles. Multiplication is commutative, so I multiply 4 times 3 to get 12. 12 times 1/2, or half of 12, is 6 square units. Because there are 6 identical triangles, we would then multiply the area of one of them times 6. Final answer, area of the shaded triangles comes out to be 36 square units. Okay, moving ahead to page number 210. Taking a look at number 4. Number 4 says a tile for a mosaic is shaped like a parallelogram. Find the area that is covered by one tile. Explain. Well, parallelogram, finding area is the same as finding area of a rectangle. We basically take the base times the height, or in this case, we could call it the length times the width. So we take 5.5 and multiply it by 3.5. Quick refresher on multiplying fractions. We need to change these to improper fractions by multiplying the denominator times the whole number and then adding the numerator. So we'd have 11 over 2 times 2 times 3 is 6, plus 1 more is 7 over 2. Multiply straight across, 77 over 4. Changing that improper fraction back to a mixed number. Take the numerator divided by the denominator. 4 goes into 7 one time. 1 times 4 is 4. Subtract, get a remainder of 3. Bring down the next digit of 7. 4 goes into 37 9 times. 9 times 4 is 36. Subtract with the remainder of 1. So the area of this figure is 19 1/4 because you take the remainder and place it over top your divisor, labeling all area answers in square units. Final answer would be 19 1/4 square inches. Number 5, refer to the trapezoid at the right. Describe how you can find the area of the triangle, or of the trapezoid, I'm sorry. The area of the trapezoid can be found by, and it also says sketch the figures you would use. So I'm going to go over here and draw 2 vertical lines to create 2 right triangles with a rectangle in the middle. So describing what we would do, find the area of the rectangle, and add the areas of the triangles. Okay, number 6 says find the area of the trapezoid in problem A. I'm going to label the rectangle A and the triangles B. So to find the area of rectangle A, we just take the length times the width, which would be 3 8/10 times 6 5/10. I know you have a calculator, so you multiply those together, give you a area of 24 7/10 square centimeters for the rectangle. For the triangles, I'm going to put formula for triangle is 1/2 times the base. Well, to find the length of the base, we have to take 10.6 or 10 6/10 and subtract 3 8/10. And then once we find the difference of those two numbers, we divide all of that by 2 because there are 2 identical bases of these triangles up above. So to find the length of one of those bases, take 10.6 minus 3.8, divide that by 2. The base of one triangle comes out to be 3 4/10. And we need to multiply that by the height. The height is given, which is 6 5/10. So the area, when you multiply those together, comes out to be 11 5/100 square centimeters. Because there are 2 identical triangles, we would take that value times 2. So the area of the 2 triangles comes out to be 22 1/10 square centimeters. So finding the area of the entire trapezoid, we would take 24 7/10 and add 22 1/10. So total area of that figure comes out to be 46 8/10 square centimeters. Uh-oh. Why is it doing this? This is no good, folks. Huh. Well, that's interesting. I'll just move it up along with it. Okay, taking a look at number 7. Number 7 says Vasco needs to find the area of the 4-pointed star. Taking a look at that, I'm going to label the rectangle A and the 4 triangles. Because there are 4 identical triangles, I'm going to label them all as B. Find the area of the rectangle. So we take length times width, so 1 1/2 times 1 1/2. That comes out to equal 2 1/4, and this would be in square centimeters. For the triangles, we got to find the base and multiply it by the height and multiply it times 1/2. So 1/2 times the base. The base is 1 1/2 because that's the length of the side of the square, times the height, which is given, of 2 4/10. So finding the area of one of those triangles comes out to equal 1 8/10 square centimeters. Please do the work along with me and check my work to make sure I'm doing correctly. So to find the area of all the entire 4-pointed star, we take the area of the rectangle and add the area of 4 times the area of one of those triangles. Comes out to equal 9 45/100 square centimeters. Okay. Okay, taking a look at the next page, read the example at the top. Once you're done reading, unpause the video, and I'll guide you through 1, 2, and 3. Okay, taking a look, it said a stop sign. A stop sign is an octagon. That just means an 8-sided figure. They broke that octagon down into triangles and rectangles. It says in the example, why were area B and area C multiplied by 4 and A was not? That is because there are 4 area B's and C's, but only one area A. So they multiplied by 4 times B and C because there's 4 of those areas and there's only one area A. Number 2, how do you know the dimensions of rectangle B? Well, if we look, the length is given. And that length that is given is 12.4. To find the width, we got to do a little bit more work. If you study the diagram, it says to find the width, we have to subtract so I'm going to say it can be found by subtracting 12.4 from 30 and then dividing by 2. All right, study the diagram if you're unsure of how I got that. Number 3, very similar to number 2. What about triangle C? Well, the height is given, which is 8 8/10. It is given. I like those. To find the base, though, we have to do a little bit more work. The base can be found by, once again, subtracting. In this case, the value is 12.4 again, or 12 4/10 from 30 and multiplying, and dividing by 2. Okay, let's move on to the next page. Okay, taking a look at page 212, number 4, if we look at that, it says show how you can divide the figure at the right into polygon whose areas you know how to find. I'm going to draw a diagonal line straight across there. That is so that we have split this figure into 2 parallelograms, and I know how to find the area of a parallelogram. Again, same as area of a rectangle, base times height, or again we could describe that as length times the width. So we have 2 identical parallelograms. So it says find the total area of the figure in problem 4. To do that, we are just going to multiply the length times the width, which means I got to take 10 1/2 and multiply it by 7 1/2. So finding the area of one of those parallelograms comes out to be 78 3/4, and we would call that in square inches. Because there are 2 identical parallelograms, I would take the value of 1, multiply it by 2, and 78 3/4 multiplied by 2 comes out to be 157 1/2 square inches. Number 6, Pedro says the solution to problem 5 is 78 3/4. How did he get that answer? Well, it's pretty easy to see from our work above. Pedro did not multiply by 2. All right, looking at number 7. Show how you can divide the figure at the right into polygon whose areas you know how to find. So we're taking an irregular shape, or what's called a composed shape. I'm going to draw a horizontal line here, a horizontal line here, and a vertical line there to create, I'll label this rectangle A, rectangle B, and these two triangles are identical triangles as rectangle C. Sketch each figure and label its dimensions. Okay, so I'm going to draw A, labeling its dimensions. Its dimensions are 7 and 2. 7 and 2. Scratch that. 5 and 2. Thank you. Take a look. Make sure you understand where I got 5 and 2. For rectangle B, if I sketch that rectangle, rectangle B is 2 units wide and 3 units long. Triangle C, if we look, the base of triangle C is 2 units. The height is 2 units, so we would have 2 units by 2 units. Letter C, find the total area of each figure. So the area of figure A, 5 times 2, which is equal to 10. Figure B, 3 times 2, which is equal to 6. And then C, we got to use area of a triangle, so 1/2 times 2 times 2, or base times height, which is equal to 2. So the solution, finding the total area of that composed shape above, I would take the area of A plus the area of B plus 2 times the area of C. And I'm multiplying the area of C times 2 because there are 2 triangles that are the same size. For letter C, adding those all up, total area comes out to be 20 square units. Okay, let's move on. Okay, these next 2 pages take us through finding the area of composed figures differently, and it's by using subtraction. We talked a little bit about this in class, where we draw a larger outside rectangle and then we subtract parts from that. So read the example above, and I will guide you through numbers 1 through 4. Okay, looking at number 1, it says, what is the area of the large rectangle? To find the area of the large rectangle, length times width, the total length, and I will trace that large outside rectangle as best as I can. The length and width, 150 times 75. So the total area of that large rectangle comes out to be 11,250 square yards. Number 2, find the dimensions of rectangle A, then find the area of rectangle A. Show your work. The length of rectangle A is 40 yards. It's given. The width, we have to do a little bit more work to find. The width is going to be the total width of the rectangle, which is 75, minus this part of the rectangle here, which is 25, which gives us a width of 50, but because there are 2 rectangle A's, we need to take that and divide it by 2. So the width of rectangle A comes out to be 25 yards. So it says then find the area. Well, the area of rectangle A is equal to 40 times 25, which is equal to 1,000 square yards. Number 3 says explain how you can find the dimensions of triangle B. The base, I would use the math to find the base of triangle B. I'm going to take 150 and subtract 100 and also subtract 40, which would leave me the base to be 10 yards. The height, similar work, different values. The height is going to equal the total 75 of the rectangle minus the width of rectangle A and the width of the other part of that rectangle. So the height of that triangle comes out to be 25 yards. Find the area of that triangle. For triangle B, area is equal to 1/2 times the base, which we said the base is 10, times the height of 25. So the area of the of the triangle, 125 square yards. Okay, number 4 then says find the area of the parking lot. Explain your calculation. Well, the area of the parking lot is going to equal 11,250. That's the total area of that large rectangle minus 2 times 1,000. I'm multiplying 1,000 times 2 because there are 2 rectangle A's up above, minus the area of the triangle, which is 125, which comes out to equal 9,125 square yards. And again, I subtracted. So to explain, I subtracted the area of the rectangles and triangles from the large outside rectangle. Okay, moving on to the next page. Okay, number 5, side of a barn has the shape shown. Use subtraction to find its area. So I'm going to draw a large outside rectangle around that barn. The area of the rectangle, the large outside rectangle, is going to be 100 feet times 100 feet, which equals 10,000. So the area of the outside rectangle has an area of 10,000 square feet. From that, I need to subtract the area of these 2 triangles, and I will label them B. So the triangles, I got to find the area of one triangle and then multiply it by 2 because there are 2. So to find the base of that triangle, I'm going to take 100 and subtract 50 and then divide that value by 2, which gives me a base to equal 25. And the height, again, studying the diagram, if you look, the height of that triangle is going to be represented by just taking 100 and subtracting 75, which also equals 25. So finding the area of one of those triangles, 1/2 times 25, which is the base, times the height, which is 25. Area comes out to equal 312 5/10 square feet. So to find the area of the barn, we are going to take 10,000, which is the area of that outside rectangle, and subtract 2 times 312.5. And again, I'm multiplying by 2 because there are 2 triangles that each have an area of 312.5. So finding my value, comes out to equal 9,375 square feet. All right, looking down at number 6, Jasmine solved the problem 5. She says this expression, I'm going to write this expression below. So it's 100 times 75 plus 50 times 25 plus 1/2 times the 25 times 25. Do you agree? So if I study that diagram over there at the right, rectangle A could be found by multiplying 100 times 75. So she's correct to find area of rectangle A. Rectangle B is 50 by 25, and we would take 100 minus 75 to get 25. So this is rectangle B. So that part of the expression looks good. This right here, 1/2 times 25 times 25. If we find the base and height of triangle C, the base and height of triangle C is 25. This is where she made her mistake. If we look and see, she multiplied 1/2 times 25 times 25, which would find the area of one of those rectangles. So, Jasmine, I disagree with Jasmine. Explain her error. She should have multiplied triangle C by 2, because there are 2 triangle C's. Okay, last one, number 7, find the area of the stop sign using subtraction. Okay, I'm going to draw a large outside rectangle. Ooh, I didn't draw that very good. That's okay. I did my best. So to find the area of the rectangle, that red rectangle, length times width, pretty easy. Dimensions are given, 30 times 30, which equals 900. So the area of the rectangle, 900, we need to subtract the area of these 4 triangles. Those 4 triangles all have the same area, so I'm going to find the area of one and then multiply it times 4 to find, and I'm going to put it down here, the height of the triangle. My work would be, looking at that diagram, I got to take 30 minus, I'm sorry, here, it's given. Let's just use that. Okay, so the height, or I'm sorry, the base is given here of 12, man, I can't talk, I'm sorry, 8 8/10. The height is also given up here of 8 8/10. So the base and the height of the triangle are both given to us. We know they're all identical, so therefore to find the area of one of those triangles, we're going to take 1/2 times 8 8/10 times 8 8/10. Area of one of those triangles comes out to be 38 72/100 square inches. So to find my area of the stop sign, I got to take the area of the rectangle, which is 900, and subtract the area of 4 of those triangles. So I'm going to take 4 times 38 72/100. Finding the area comes out to equal 745 12/100 square inches. Okay, so this leaves you about 20 minutes, folks, of time to work on your homework. If you follow along and work, stayed on task, your homework is page 215 and 216. Guiding yourself through those 2 pages. So good luck to you. I will see you tomorrow. And please get your homework done, page 215, 216. Thanks. Have a great day.